Next, we're going to be looking at how to factor a perfect square trinomial. So just like difference of squares trinomials, we have to be able to identify a perfect square trinomial. Okay, so just remember, the perfect square is a number that you get by multiplying another number by itself. So listed here are a couple of perfect squares, or the first couple of perfect squares, but there is an infinite number of perfect square numbers. You should at least be able to identify these 10. Okay, so a perfect square trinomial is a trinomial expression that you get from the product of two like binomials, or when you square a binomial. What does that mean? Okay, let's look at the general binomial a plus b all squared. So we're squaring the binomial a plus b. If we square this binomial expression, remember our special product pattern for squaring a binomial. We square the first term, and then we multiply our terms inside of our bracket. So we have a times b, but then we're going to multiply that product by 2. So we're going to have 2ab, and then we square the last term, which is going to give us a b squared. This expression here is called a perfect square trinomial. So just like the previous example, we went from the factored form to the expanded form, and that's a perfect square trinomial. Now, if you're given a perfect square trinomial, we're going to work on being able to go back to the factored form. Okay. If we had a binomial squared that had a subtraction sign in the middle instead of a plus sign, the only difference to this expression compared to the previous perfect square trinomial expression would be that instead of having a plus sign here, we're going to have a minus 2ab plus b squared. So this would also be a perfect square trinomial, but just notice that the sign here depends on the sign inside of your binomial. So keep that in mind. Okay. So this is also a perfect square trinomial. Perfect square trinomials are quadratic equations which are the result of squaring a binomial, as we just saw. Okay, so we already did our special products by finding patterns to squaring a binomial to get some trinomial expression. Now we're going to take that trinomial expression that we get, which we now call a perfect square trinomial, and work backwards to get to that factored form. So let's quickly recap expanding our square of binomials. And again, we're going to be using our pattern, so we're going to do this quickly. But we can also recap using FOIL to do this. So FOIL would give us x plus 3, x plus 3. So we're just expanding that square to show the product of two like binomials. And then we're going to multiply the first, multiply the outside, multiply the inside, and then multiply the last. And that's going to give us x squared plus 3x plus 3x plus 9, which will simplify to x squared plus 3x, plus 6x plus 9. All right, using our quicker method, we would get, so using the pattern, we're squaring the first term in our binomial, x squared, and then we're multiplying the 3 times the x, all times 2, which is going to give us 6x, and then we square the last term. All right, if you've mastered this pattern, it makes it so much more efficient. If you have to go back to FOIL, as we said in the last video, on the product of squaring a binomial, then that's perfectly fine. Okay, but as you do more and more of these, you'll get quicker and quicker. Okay, B, using our pattern instead of our FOIL, We're going to square the first. So 2x all squared is going to give us a 4x squared. And then we multiply our two terms inside of the bracket. So 2x times -4, right? Remember the sign in front of the term applies to that term. Is going to give us a -8x. All times 2 is going to give us a -16x. And then we have -4 all squared is going to give us a +16. Straightforward. Okay, so we just went from our binomial squared to our perfect square. Now we're going to work to go from our perfect square back to our binomial squared. So the simplified expression that you obtain from each of the squared binomials are perfect square trinomials. How do we recognize a perfect square trinomial? Well, let's use this example here, and we're going to check off. So, when analyzing a trinomial to determine whether it is a perfect square, look for the following. The first term has to be a perfect square. So, first term is our 4x squared term here. Is it a perfect square? Yes, it is. The last term is a perfect square. So, this is our last term here. It's 16. 16, yes, it is a perfect square. I'm just going to check off in its boxes too. And then our middle term is the product of the square roots of your first and last terms. So the square root of 4x squared is equal to 2x. The square root of 16 is equal to 4. The middle term has to be the product of the square roots of your first and last term. So 2x times 4, all times 2, because it's twice that product. So 2x times 4 is 8x, times 2 is 16x. Yep, that works. Okay. So that is a perfect square trinomial. If you know that it's coming from a binomial squared, then you automatically know that it is a trinomial. But if you're given any trinomial and you're asked to factor it, we need to be able to identify it as a perfect square trinomial. So let's look at these examples here. We're given the trinomial, three-termed polynomial expression, x squared plus 10x plus 25. Is this a perfect square? Well, let's run down our list, our checklist. Is the first term a perfect square? We have x squared. Yes, it is. Is the last term a perfect square? 25. Yes, it is one of our perfect squares because 5 times 5 gives us 25. And then the middle term, is it twice the product of the square roots of our first and last term? Well, the square root of x squared is just x, and the square root of 25 is 5. So the twice the product of x times 5 is equal to 10x. Yep. So this is a perfect square. Let's check this next expression. Okay, so we have 4x squared minus 25x plus 36. Is this a perfect square trinomial? Well, first term has to be a perfect square. We have 4x squared. Yep, that's perfect square. Coefficient is a perfect square, and the variable is also being squared. The last term is 36. That is a perfect square. Is the middle term the product or twice the product of the square root of your first term and your last term? Well, the square root of our first term is 2x. The square root of our last term is 6. And we want the product to be twice the product of 2x times 6. So 2x times 6 is 12x times 2 is equal to 24x. That did not work out, right? Our middle term here is 25x. Ignore the sign, right? The sign will indicate something else later on in our factored binomial expressions. But we have 25x in our expression, and the product of, or twice the product of the coefficient or the square roots of our first and last term gave us 24x instead of 25x. So this is not a perfect square. If you can recognize a trinomial as a perfect square, then you can use a very easy and efficient method for factoring these trinomials. So the steps for factoring a perfect square trinomial is to 1, always check to see if the trinomial is a perfect square. The second is to then, once you identify your trinomial as a perfect square, you're going to square root the first term. That's going to give you the first term of your binomial in the factored form. Then you're going to square root the last term of your trinomial. That's going to give you the last term of the binomial in your factored form. The first and last term will be separated by the sign that is applied to the middle term in the original trinomial. Right? So just to go up a little, remember we said that this sign here indicates the sign within your binomial. Okay, and we saw that when we were going the other way, when we were expanding the square of a binomial as well. So the square the whole binomial to give you a plus or minus b all squared, right? So the plus or minus is going to depend on the sign of your middle term of your expression. Okay, so let's see if we can apply our perfect square trinomial method to this example. First, we got to check. So, and some of you will be able to just look at this expression and you don't have to show the checklist, right? You don't have to show that the first term is squared, the last term is squared, and the middle term is the twice the product of the square roots of the first and the last. But some of you have to write it down. So write it on the side. That doesn't have to be part of your solution. Okay, so we have 16b squared. That is a perfect square. 25 is also a perfect square. The middle term, let's see if that works with our first and last term. 16b squared, the square root is 4b. 25 square root, well, the square root of 25 is 5. Twice the product of those two square roots, so 4b times 5 is 20b, times 2 is 40b. Yep, so this is a perfect square. Now let's factor. So we know that the factored form is going to be some binomial squared. So we need to figure out what our first and our last term of our binomial is. We know already that because of the sign in between here, or of the middle term, that there's going to be a subtraction sign separating our two terms of our binomial. Okay, so what is the first term of our binomial? It's going to be the square root of your first term in your trinomial. So 16b squared, as we said, the square root is 4b. And then 25 square root is 5. So the factored form is 4b minus 5 all squared. All squared because you're squaring the whole binomial, not just one individual term within the binomial. Okay, so identifying it as a perfect square allows you to use this fast and efficient method of factoring in order to get your factored form. Let's try some more. So in this problem, you are already given that these are all perfect square trinomials. But again, if you were given a question that said factor if possible, not identifying what type of trinomial this is, whether it's a simple, complex, a perfect square trinomial, you would have to be able to identify it as a perfect square trinomial. Okay, so the first thing that you look for is your first and your last term. If you see that your first and your last term are perfect squares, then that's going to be an indicator that this may be a perfect square trinomial and we should try checking for the middle term. So we have 4x squared, 9, perfect squares. Okay, square root of 4x squared is just a 2x. And the square root of 9 is 3. If we take twice the product of those two square roots, we're going to get 12x. Okay, so yep, that's a perfect square. We already knew that from the question, but again, we want to check if that's not indicated. So we know that the factored form is going to be a binomial squared. What is our terms in the binomial? Well, it's going to have a first term, that's the square root of your first term of your trinomial. Last term is the square root of your last term of your trinomial. And the sign in between your two terms in your binomial is going to be the sign of your middle term in the trinomial. Done. That's it. Again, we already know that this second question, B, is a perfect square. So in order to factor this, square root of the first term is going to be 3x. Square root of the last term is going to give us 4. And the sign in between is minus because of the negative attached to your middle term of the trinomial. All squared. Don't forget that square. That'll probably be a half mark or a mark off. Awesome. Okay. Again, given in the question that this is a perfect square. So for question C, the factored form is going to be the square of some binomial. The first term of your binomial is going to be the square root of your first term of your trinomial, so x. The last term is going to be the square root of your last term of your trinomial, which is 5. And because there's a plus sign on your middle term of the trinomial, there's going to be a plus sign inside of the bracket. Easy breezy, right? Again, being able to identify your trinomial as a perfect square allows you to use this fast and efficient method. If you are unable to identify your trinomial as a perfect square, then you can revert back to either your simple trinomial factoring or your complex trinomial factoring method of guess and check. All right, that will also work for a perfect square trinomial. Let's try that for question C. We could also do that for the other questions, especially if you're unable to identify as a perfect square. Okay, so guess and check. So just to recap, factoring any trinomial, whether it's a perfect square or otherwise, remember we said to factor a trinomial, you will always get the product of two binomials. What are those two binomials? Well, looking at your first term of your trinomial, we know that the first terms of the binomials have to multiply to give us an x squared. So that means that this has to be an x and this has to be an x. The last terms of your binomials have to multiply together to give us the last term of the trinomial. So what are we going to multiply together to give us 25? Well, using our guess and check method, running down the different combinations to get a 25, we can multiply a 1 times 25. 2 doesn't go into 25, 3 doesn't go into 25, 4 does not go into 25, 5 times 5 gives us 25. Okay, and now we have to look at the combinations that will add together to give us a 10x. Well, as we said before, looking logically, no combination of 1 and 25, whether or not they're both positive or both negative, is going to get us anywhere close to 10. So that's gone. But if we have a 5x plus another 5x, that's going to add to a 10x. So that means that there's going to be a 5 as the last term of each of our expressions. And because they were both positive 5x's to give us a 10x, then we're going to put a plus in between, right? But x plus 5 and x plus or times x plus 5 is equivalent to writing x plus 5 squared, which is what we had over here, just by identifying that this is a perfect square. But again, as I said before, if you're unable to identify perfect square trinomials, we can always revert back to our trinomial factoring using guess and check. So make sure that you do the homework questions that have been assigned for this section, which is section 3.7 of your textbook. If you have any questions, make sure that you ask, and good luck factoring.